Open your eyes and see around. You will find dozens of applications of data mining which you are using and interacted with in your daily life. Data mining is applied almost everywhere. So hello, myself Sumaiya Reza and your instructor for data mining. Today I want to cover decision tree. Decision tree is a type of classification algorithm which comes under the supervised learning technique. So before learning about decision tree, I will give you a short introduction of classification. Now, once you get your fundamental class, you will jump to the decision tree part. So let's move ahead and start with what is classification. I hope everyone you have almost have used Gmail. So how do you think the Gmail is getting classified as a spam or not a family? Well, there's nothing but classification. So what is classification? Classification is a process of dividing the dataset into different categories or groups by adding label. So basically what you are doing in you are take data, analyze it, and on the basis of some conditions you finally divide it into various categories. There are the several different ways to train the machine and you can choose any of them. The most common of them is decision tree, which we will cover in depth in today's session. Decision tree is a graphical representation of all possible solutions to a decision. To draw decision tree, you have to find out the class attribute and target attribute from your dataset. Then calculate the information gain of class attribute. Calculate entropy of all attribute except target attribute. Then subtract the information gain and entropy. Then we will draw the decision tree. Now the law of Ig is minus p by p plus n log 2 p by p plus n minus n by p plus n log 2 n by p plus n. Now we will see an example, calculate it, and finally draw the decision tree. Here we can see a dataset, and in this dataset have various type of attribute like age, gender, blood pressure, cholesterol, and drug A. The attribute of age have various type like young, middle age, and senior. Gender have female and male. Blood pressure have high, normal, and low. Cholesterol have normal and high, and drug have drug A and drug B. Now we have to calculate information gain and entropy, and finally we make a decision tree. First steps: drug A have 5 times and drug B have 9 times. So the information gain of drug will be equal minus 5 by 5 plus 9 log 2 5 by 5 plus 9 minus 9 by 5 plus 9 and log 2 9 by 5 plus 9. Here 5 is a p and as a p and 9 as n. After calculating this, we will find the value of information gain of drug is 0.94. Now go to the second steps. In these steps, we have to calculate all attribute entropy. So we have to make table for all attribute. First of all, we take the attribute age and make a table. Age has various type: young, middle age, and senior. And the target attribute value is drug A and drug B. Then young and take drug A is 3 and young take drug B is true. Then middle age take drug A, none. That's why in this field we put 0. Then middle age take drug B is 4. Senior take drug A is 2 and senior take drug B is 3. Then calculate the IG of young. IG means information gain. So equal minus 3 by 3 plus 2. Here 3 is comes from here and 2 is comes from here. After calculating this, we find 0.97 entropy, and then calculate the entropy of young. Entropy is the information gain of young into probability of young. So we calculate before the information gain of young is 0.97 and the probability of young is 5 by 14. Here 5 is the probability of young, so the entropy of young is 0.35. The middle age of Ig is 0 because of its have a value of 0. We see the table, middle age have value of 0. So after calculating we find the information gain of middle is 0. If information gain will 0, then entropy will 0. Then we have to calculate the information gain of senior and we find 0.97 and entropy will 0.97 in the probability of senior. The probability is senior is 5 and 14 is the value of total columns. Now we have to calculate the total entropy of age. The total entropy of age will be the summation of all attribute. So 0.35 plus 0 and 0.35 and the total result will be 0.7. Then we have to calculate similarly for gender attribute. Here the table of gender. Then calculate information gain and entropy of female, information gain and entropy for male, and calculate the total entropy of gender, summation of this one and this one. Then we have to calculate also blood pressure, and this is a table for blood pressure. Then calculate all information gain and entropy. Then finally we find the blood pressure entropy is 0.90. Then similarly cholesterol also calculate by this table, information gain entropy and get total entropy is 0.98. Then go to the step 3. Here we find we declared the information gain of all attribute. We take all attribute here and it's is a summation of all attribute information gain to their all entropy. 0.94 is information gain of drug dataset and 0.7 is the total entropy of age. Then we get 0.24. Gender also information gain is 0.94 and 0.78 is the total entropy of gender. 0.90 the total entropy of blood pressure and 0.89 is the total entropy of cholesterol. Then calculating this summation we get this value. Here we can see the largest value is age, which is 0.24. Then the second largest value of gender 0.16 and then the third value of cholesterol which is 0.05 and lastly the value of blood pressure is 0.04. Then go to the step 4. Then we make a decision tree. Here we put age, but why we take age? Here we can see the largest value is age. So we take first the age attribute. Then from this data set we know that the age has three type of variables: young, middle age and senior. If we take young, then what child node we have to go? From data set, here age attribute young. Now we have to find all young belongs to drug A or drug B. Here young drug A, young drug A, young drug A, but here young belongs to drug B, so we cannot go via young from drug A or drug B. So in this case we have take the second largest of entropy. The second largest of information gain of attribute is gender. So in this case we take as a child node of gender. Then we take the node is gender. Then gender have two categories of variables, which is female and male. And if we find the female, young and female is belong to drug A, that's why we take the child node is drug A, and young and also male take drug B. After that the age value of middle age belongs all the value of drug B, so we directly connect the child node is drug B. After that the age is going to via senior value, then the similar of young. So in this case senior not only belongs to drug A or drug B, so we have to choose the another attribute. So what we which variable we take? In these variables we take age and gender, and blood pressure and cholesterol we haven't used. In these two variables the largest variable is cholesterol, so we have to take cholesterol as a child. So we take cholesterol, and cholesterol have also two variables, high and normal. So age senior and her or his cholesterol is high, then he take drug A, and age is senior, he or she cholesterol is normal, then go to the drug B. So finally this is the decision tree of this dataset. That's all about today's class. I hope you all enjoy the class, and if you have any questions you can ask me in the discussion forum. Thank you.